You sound good. You sound good. Just keep distance. All right, we're going to start Unit 1B. This is the last part of this unit today. So we're on day 4, which is essentially the last day of the unit. We'll do a little bit more with it tomorrow. But today we're going to talk parent functions. So a broad scope today, kind of a broad view of functions themselves. Just looking at parent functions, what we want to be able to do kind of today is we want to be able to identify what function is being shown to us. You're going to get, I think, 6 different parent functions, and you're going to be given an equation. You're going to ask to identify it. Is it cubic? Is it linear? Is it absolute value? What is it? And then you're going to be asked to describe the translation of it, and then sketch kind of the graph of it. So we've got 6 parent functions that we're going to talk about today. Essentially, a parent function is a base form of every function in the family of functions. Okay, so it's just the base form of what it looks like. And all I want you to do is you can put definition up there, but then I just want you to write linear, f of x is equal to x, and then just draw a graph. And then write absolute value, f of x equals, don't do the table. I'm going to put up Desmos here in a second and show you what each of them look like so you can graph them. Because you want to be able to identify them by what the graph is, as well as seeing the function itself. But this is just the baseline. Nothing added to it, nothing multiplied to it, nothing subtracted to it, nothing divided by. It's just, parent functions are just the basics of that particular functions. So a linear function, you've dealt with linear functions a lot. A linear function is something that's in the form f of x is equal to x. And again, you can add things to it, you can multiply things to it, you can do all of these things to it, but it is just a certain graph, kind of the same thing with the absolute value. Absolute value of f of x is equal to the absolute value of x. That's an absolute value graph. So what those 2 graphs look like. So a linear graph. Linear is just a line. That's the graph. Okay, it's a graph that goes through the origin, has a slope of 1. It's just a line. Linear means line. So that's what the linear graph looks like. So in your notes, just draw a linear line. Okay, that has a slope essentially of 1. Okay, so that's the parent function for something that's linear. Absolute value function is a v, where again at 0, 0 is kind of where they come together. So any function that has absolute value of it, and that's absolute value and the x is inside of the absolute value symbols, it's going to look like a v. And again, it's going to move around depending on what I add or subtract or multiply to it, and even how I go about doing that. But that's what the parent function of absolute value looks like. So we've got linear with just a line. Absolute value then becomes the v. The next 4 that we're going to talk about, I'm going to have you write them all down, and then we'll go over what each one of them takes so we don't have to go back and forth. Well, we've got a quadratic. Quadratics you've dealt with in the past. F of x is equal to x squared. That's kind of the parent function for a quadratic. For a cubic, it's f of x is equal to x cubed. Again, we'll show you what these look like in just a second. Just give yourself some room so you can sketch it. Cubed root is f of x equals x cubed. And then square root, f of x is equal to the square root of x. And then cubed root, f of x is equal to the cubed root of x. And all these have different basic shapes that they are going to take on. Okay, so So we've got quadratic, cubic, square root, and cubed root to go along with the linear and absolute value. So when we look at each of them, quadratic is our basic U. You've seen the quadratic one. Again, if you didn't have time to write it, it's f of x equals x squared. It's going to look like a U. Okay, you've seen these before. You've dealt with these a lot in Algebra 1. We'll deal with a lot more of these as we go through Algebra 2. So that's what the quadratic one looks like. Cubic. Here's the graph of the cubic. And it comes up, has the origin at 0, 0 again, kind of, and then kind of goes up, kind of exponentially, kind of type of situation. Okay, so that's what a cubic is going to look like. Again, that's f of x equals x cubed. The next one, square root, f of x equals x squared. Kind of looks like that. Again, notice it stops at 0, 0. Probably makes sense. Can't really take the square root of -1 yet. Or we can, but it's a complex number. And then the last one, cubed root. Cubed root looks like that. So those are our six parent functions. Okay, we've got linear, we've got square root, we've got quadratic, then we've got cubic, square root, and cubed root. So now what we want to be able to do is we want to be able to identify which one we're looking at and then talk about what translation that it's having. So for example, then in your notes put f of x equals x plus 6. F of x equals x plus 6. So by type, what's the parent function? What is it? Okay, it's linear. Okay, so we know that this is a linear function. Now we want to be able to describe the translation. So here's what the graph of that one looks like. This is Tony.
I found some web results. I can show them if you ask again from your iPhone.
That's right. Yeah. Okay. Yep. Bye. Okay, so this is what that graph looks like. What do you notice? What has happened to it from the parent function? If I zoom in here a little bit, what's happened from the parent function? Remember what the parent function looks like. The parent function looks like that. What has happened to it? It moves what?
Away from north.
What? The y value increases by how many? 6. Okay, so we can say it moved up 6, right? Okay, now this one looks like it moved left 6 too, right? That's not the case. That just happens because our slope is 1. That doesn't always happen, but this does. Okay, that's going to go up 6. Okay, that's kind of one of the things that it does. Okay, so that's going to go up 6. So the next one. So in your notes put it goes up 6. Up 6 for that last one. So this next one. Function for this is f of x equals the absolute value of x plus 1 minus 3. Okay, so what type of graph is it? Absolute value. So this is an absolute value graph. So if I was going to graph this, this is what our new graph looks like. This is what the original graph looks like. Let's talk about what it's done. Okay, so what has this done? From the green to the blue, what has it done? And when I'm talking what it's done, I'm talking about what has this done? What has the origin done? It's gone down 3 and left 1. So in your notes, put down 3, left 1. Okay, that's called the translation. It's moving down 3 and it's moving left 1. That's called the translation for that point. Okay, let's look at the next one. So here's the next one. F of x is equal to negative. Parentheses, x minus 6 squared minus 3. So what type is it? It's quadratic. Okay, so it's going to be a u, right? So it's going to be a u, maybe. Okay, let's take a look at what this graph looks like. Come on, go away. No, don't go away. Shrink. Okay, so there's that graph. There's our original graph. Okay, so let's talk about what it did. Zoom in a little bit. What has happened going from our original, the purple, to the new one, the green? What has happened to the x value?
If your last name starts with W, X, Y, or Z, and you need your picture taken, please report to Knowlton. Students whose last name starts with W, X, Y, or Z, and you need a photo, please go to Knowlton Auditorium.
What has happened to the x value? It's gone. Which way has the x value gone? It's gone right. How many? 6. Down. Down 3. And what else has happened? It flipped. Good word. That's the word that we'll use. So we say that this went right 6, down 3, and it flipped. This is what that did. Okay. Good so far? All right, the next one. F of x equals 1/2 times the square root of x minus 3 minus 5. Okay, so now here's what I wanted you to do with this one before I show it up there on the graph. I want you to think about what the translation you think the translation is going to be. If you look back on the ones that we've just done, there's a correlation in there. See if you can find the correlation in there, and then see if you can describe the translation that this one is going to have. So name it, square root, I said it. See if you can figure out what the translation is, and then see if you can come up with a general statement for it. Work together, give you about 1.5 minutes, 2 minutes to see if you can come up with what the translation is, just by looking back on the ones we've done, and then tell me what it is. Go, go, go. Right. You stick your face inside of the light for the thing. It's bright. Shocking. When I go like this, that flashes in my eye. It's bright. Shocking, isn't it? Don't worry about the half so much. We haven't really done. Don't worry about the half. That does do something. Well, when you see the picture, we'll figure that out. Figure the rest of it out. Are we ready? So what's the translation going to do? X value. What's going to happen to the x value? It's going to go right 3. It's going to go right 3 and down 5. Okay, so this is going to go right 3 and it's going to go down 5. So let's put then because that's right. It goes right 3 and down 5. But does that correlate with everything else that we've done? Okay, so what statement can we make about the x value? What kind of happens to the x value? This one goes to the right, but if we want to make a general statement, what can we say? If I just look at the x values, if I just look at what's happened to the x values, what can we say? There's something they all have in common that have moved through the x. What do they have in common? Did the first one move at all? It went up and down, right? What do the rest of them have in common? They went left or right, but how did we know it was going to go left or right as opposed to going up and down within there? What's different? What's different? They're inside parentheses. Okay? If it's inside parentheses, so you've got that x value inside parentheses, or you have it inside of absolute value, or you have it underneath the radical symbol. Okay, that's telling you what your x value is going to do. And your x value is going to do opposite of what you think it's going to do. Okay, so if it's negative inside parentheses, negative actually means it's moving right. Negative is right, positive is left. So this is going to move, this moved right 6. This moved right 6. This moved left 1. So if it's inside parentheses, it's actually the opposite of what you see. Okay, so positive means left, negative means right for your x value. Positive is left, negative is right for your x value. If it's inside parentheses, absolute value, or it's underneath the radical. What does the number outside do? It moves it up or down, and it's exactly what you see. This one moved down 3. This one moved down 3. This moves down 5. So the x value, kind of a way to remember it, the x value, when it's in this form, is the opposite of what you see. The y value is what you see. Okay, so that's kind of the general statement we're going to use for this. Now, about the half that's out front. So we take that half out front. Here's what the graph itself looks like. There's the original one. What has happened to it? It's got a little flatter. Okay, it's got a little flatter. And as that number goes up, it's going to get higher, so to say. So it's got a little flatter. We're not going to worry about that number so much. We're just kind of worried about the x values and the y values. Okay? So now let's look at the next one. So if we look at the cubic one, f of x is equal to 2 times the cubed root of x plus 4 plus 1. Now, without even looking at this graph, we can say that it's a cubed root one, right? And it's going left, how many? 4 and up 1. That's what it's doing. It's going left 4 and it's going up 1. Okay, so we would say, if we just want to know what it is, it's cube root. Left 4, up 1, that's the translation. You're done. You move on to the next one. If you want to know what it looks like, there's what it looks like. Okay? And again, remember what's shifting when we do these. Okay? This is the piece that, so this went what? Is that the right one? Left 4, up 1. Okay, so that's the piece that's moving. And that's going to stay along there. Okay? And the last one. Number 6, f of x is equal to the negative of x minus 3 cubed plus 2. Type is cubic. Okay, so our parent function is f of x equals x cubed. Left or right? How many? 3, up or down? 2, and then what's the negative do? Flips it. Okay, so the negative 1 then flips it. So there's what that graph looks like. Oops. There's what that graph looks like opposed to the other one. And notice when it flips, it just does this. Yep. Okay? Questions with those so far? Okay. Let's look at just a couple more and we'll call it a day. We just did those. So we've got f of x is our parent function. The first one's our parent function. The second one's our new function. F of x is equal to the absolute value of x plus 3 minus 1. I want you to state the translation and sketch the new graph. State the translation and sketch the new graph. In 4, 3, 2, 1. It's going what? Left 3 and down 1. So what's that mean? Well, left 3 is my x value is now negative 3. Down 1, my new y value is negative 1. So if I graph at negative 3, 1, that's where my graph has to go. And what's the shape? It's a V. So that's all you need to do today. Just gonna sketch these. Okay? So when we say left 3, down 1, that means our new kind of starting point is going to be negative 3, negative 1. Make sense? Do we need to do any more? Don't need to do this one. We're okay? We can write the translation and graph them if we have to? All right. So that's what you're going to do today.